Alright guys, so today we're going to take a look at section 8.5, which is on polar coordinates. Now, we've already kind of talked about this a little bit, so this beginning part here is just going to be kind of a rehash of what we talked about back in the early sections, okay? Now, traditionally, we've graphed everything in good old rectangular coordinates, x comma y, right? X is how far we go along in the horizontal, right, along the x-axis, right? Y is how far we go vertically up the y-axis, and so we go over x, up y, right, making a nice rectangle, okay? However, instead of looking at that rectangle, we're going to take a look at the diagonal of that rectangle, which is the length r, and the angle formed by that diagonal and one of the sides of the rectangle. And that gives us polar coordinates r comma theta. So if we knew the length of this diagonal here, right, along with this angle formed by the x-axis and the diagonal, we would be able to talk about this exact same point where we would normally call it x comma y. Okay, now a couple of other things we've already talked about. R equals the square root of x squared plus y squared. This comes from the right triangle. And then using the three right triangle trig functions, we can get a couple other things. Tangent of theta is y over x. We've already talked about that. In the cosine of theta and sine of theta equations, we can solve for x and y. X equals r cosine theta, y equals r sine theta, and we're going to go ahead and use these later, so it's very important that we know how to use these formulas. Okay, so moving right along, let's take a look at some examples of how we can graph in polar coordinates. Okay, and so the first thing you'll notice is that the coordinate grid is no longer there. Okay, our standard x-axis, y-axis isn't really there anymore, although it's still kind of there, but not really. Okay, polar grids are circular. Okay, and let's do some practice here, see if we can graph the following coordinates. So let's start with this first one. Point P is 2 comma 30. Now remember, right, we're going off of r comma theta, right? So 2 represents the radius, and so what we're going to do is from the quote-unquote origin, 0, 0, we're going to go outwards to a circle with a radius of 2 units. Well, what circle would that be? So that would be this one right there. On that circle, we have a radius of 2. Okay, so 2 comma 30 degrees is somewhere on that circle. Okay, now to figure out exactly where, let me go ahead and erase that. To figure out exactly where, we're going to start at 2 comma 0 degrees, which would be that point right there. And we can see the angles along the sides, right? So we go from 2 comma 0 degrees and we move up along that circle to 2 comma 30 degrees, and that is point P. Okay, so find a circle with that radius and then go clockwise or counterclockwise, excuse me, like we've been doing to get to that angle, and that's 2 comma 30 degrees. Now let's find the rectangular coordinates. Well, that's x comma y, right? And this is where we need our formulas, right? X equals r times the cosine of theta. So x is going to be 2 times the cosine of 30 is root 3 over 2, which is root 3. Y is going to be 2 times the sine of theta, which is going to be 2 times 1/2, which is 1. So P is also root 3 comma 1 in our good old rectangular coordinates. Let's take a look at another one. Okay, now Q looks strange, right? How can R, the radius of a circle, be negative 4 degrees? Or negative 4 units, excuse me. Okay? Well, the answer is simple. Okay? Kind of like with the x-axis, right? Moving towards the right is positive R values, and moving to the left is negative R values. That should be a negative there. Okay? So, 2 comma 0 degrees was moving along the right there. So negative 4 comma 0 would be right there. That's negative 4 comma 0 degrees. And from there, we go counterclockwise 2 pi over 3, or 120 degrees, which would take us right there. And that is supposed to be a circle, I swear, or a dot, I mean. And that is point Q. Now, another way you can think about it is, okay, forget negative 4 comma 2 pi over 3. Let's do positive 4 comma 2 pi over 3. So radius of 1, radius of 2, radius of 3, radius of 4 would put me right there. Then I go clockwise 2 pi over 3. And now, that's 4 comma 2 pi over 3 right now where the cursor is. But I want a negative 4, so I go back to the origin. Then I go down 4 more. And that gets me to where we put Q. So that's another way you can take a look at polar coordinates with a negative R value. Okay. Now let's do one more. R is 5 comma negative pi over 4. Okay. So I'm going to go out to a circle with a radius of 5. That'd be 1, 2, 3, 4, 5. And now negative pi over 4 means I go clockwise pi over 4, or 45 degrees. And that would take me somewhere there. And so that is going to be right there. That is R, 5 comma negative pi over 4. Okay. Positive theta values, we do it like we always do. We go clockwise, or counterclockwise, excuse me. Negative theta values, we go clockwise, just like we've always done. Okay? And so that's some basics on graphing polar coordinates. Now let's take a look at something that's a little bit more involved. Give 3 other pairs of polar coordinates for the point T, which is 3 comma 120 degrees. Okay, so first of all, let's start with plotting T so we can take a look and see how we can get some other values here. So radius of 0, 1, 2, 3, 120 degrees puts me right there. And so right there is our point T. Okay, so there's a few ways to approach this. Okay, let's keep the radius, the R value, the same, but let's change the angle theta to something else. Okay, now how would we do that? Well, let's go back to the start. Okay, how do we start? We started at 3 comma 0, which would be right there. Whoops, wrong tool. 1, 2, right there. And what did we do from there? We went counterclockwise 120 degrees. Well, what's an angle that's coterminal with 120 degrees? How about negative 240 degrees? That would also get us to T. Okay. Now, we could also go any other coterminal of 120 degrees, right? We could say 3 comma 480 degrees and so on. We could subtract 360 again and again, okay? What I'd like to look at now is, what if instead of changing theta, we changed the R value to negative 3? So now let's start at negative 3 comma 0, which would be right over here. And how could I get to t? Well, the fastest way would be to go backwards, right? But since we would be going clockwise, that would be negative 60 degrees. And so negative 3 comma negative 60 degrees is another way we can write the coordinates for point T. And we could also go counterclockwise from negative 3 comma 0 at an angle that's going to be coterminal to negative 60 degrees, and that would be 300 degrees. And that gives us 3 different ways we could write the polar coordinates for that one point T, 3 comma 120 degrees. And again, just to reiterate, right, we could take coterminals for all of these angles, and there's infinitely many ways to write the polar coordinates for any one point. The typical standard, though, is to keep stuff between negative 360 and 360, or negative 2 pi to 2 pi. Okay, so the last thing we're going to look at is actually from the Section 8.5 Day 2 notes, which is conversion of equations from rectangular to polar and polar to rectangular. Okay, and I know you're excited. Yes, you can graph equations in polar form just like we did in rectangular form. We'll save that for another day though. Okay, let's just do some basic stuff here. Let's convert back and forth. Okay, let's start with rectangular polar. Y equals x minus 3. We know that's a line. So let's figure out what the equation of a line would be in polar form. And so from the first slide, I hope we remember, right, we had some equations for y and x, right? Y was the same thing as r times the sine of theta, and x was the same thing as r times the cosine of theta. Minus 3 is just minus 3. And now, to get this to polar form, we are going to go ahead and get our r's to the same side and then factor out the r. So that would be r times the sine of theta minus r times the cosine of theta equals negative 3. Let's factor out the r. We get r times sine of theta minus cosine of theta, and that equals negative 3. And now, let's solve for r. R equals negative 3 over sine of theta minus cosine of theta. And those thetas look really bad. I'm going to ask you to ignore that. Okay. Now, standard convention when we graph in rectangular form is y equals. When we're going to be doing graphing in polar form, the convention is going to be r equals. So when you're converting to polar, right, I'm going to ask that whatever equation you get, you solve it for r. Okay, let's take a look at another one. X squared plus y squared equals 4. Hopefully, we remember that x squared plus y squared equals 4 is a circle centered at 0, 0 with a radius of 2. And let's see if we get something similar to that. So, just like we did last time, let's go ahead and substitute our x and y values with our cosine theta and, our sine of theta. Set that equal to 4. And so this is going to give us r squared cosine squared plus r squared sine squared equals 4. And just like we did last time, let's see if we can solve for r. Let's factor it out from both sides. We get r squared times cosine squared theta plus sine squared theta equals 4. And now I'm very sincerely hoping we remember that cosine of theta squared plus sine of theta squared equals 1. So this is the same thing as r squared equals 4. And I'm also hoping we remember that this is a quadratic equation. And so this has two solutions, r equals 2 and r equals -2. Both of these equations represent a circle with a radius of 2. Since theta is not here, right, this means we can pick any theta and the circle, and I'm sorry, the graph would have a radius of 2, which is just like a circle. Now, let's see if we can go the other way. This might be a little bit tougher for some of us, okay? So, our big goal here in going from polar to rectangular is to try to come up with either an r times sine of theta, because we can go ahead and substitute that for y, or an r times a cosine of theta, because then we can substitute that for x, right? We're going to rectangular, so we need a y or an x in our equation. Now, if we take a look at the first example, this will give us a common theme. More often than not, we're going to have to do some cross multiplying. R equals 4 over 1 plus sine of theta. And if I go ahead and cross multiply here, I will get r plus r sine of theta equals 4. Now, unfortunately, we still have an r here that we're not going to be able to substitute with a very nice x or y, but we do indeed have an equation for r, right? R itself is the square root of x squared plus y squared. R sine of theta is just a y, and this equals 4 when added together. And this brings us to our next common technique when going from polar to rectangular. I want to get rid of this square root. So, squaring both sides seems like a very, very nice thing to do. And so, let me go ahead and subtract over the y first to the other side. I'll get the square root of x squared plus y squared equals 4 minus y. Should be a nicer minus sign. And now let's square both sides. So I'll get x squared plus y squared equals 16 minus 8y plus y squared. And what's very nice here is that the y squareds cancel out. And now, as is standard convention for a rectangular form, we solve for y. So let me bring the 16 over. And now let's divide by -8. So we get -1/8 x squared plus 2 equals y. And this is a downward opening parabola, right, with a very wide U shape, and it's been shifted up 2 units. Let's take a look at another one. R equals 2 sine of theta. Now, I'm not going to be able to get y and x in here, right? Because I could divide both sides by sine, but r over sine does not equal y, it's r times sine. And so, let's try something new in here, right? We already have the sine of theta on the right-hand side here, but if we had an r, that would be just dandy. So let's go ahead and multiply both sides of this by r. And that would give us r squared equals 2r sine of theta. And so we already pointed this out. If r was the square root of x squared plus y squared, then r squared is going to be just x squared plus y squared equals 2, and then r sine of theta is just going to be y. And now I can see that I have x squared plus y squared, which means that this is going to end up being a circle. Now, when you know you're going to have a circle, right, x squared plus y squared again, right, you do not have to solve for y. Let's just write it like a circle. So let me go ahead and subtract the 2y over, so we get x squared plus y squared minus 2y equals 0. And now I'm going to have to complete the square with my y terms. So I take the coefficient of the y term, negative 2, divide it by 2, and square it. Negative 2 over 2 is negative 1. Squared is positive 1. And so I add 1 to both sides. So I get x squared plus y squared minus 2y plus 1 equals 1. And this becomes x squared plus trinomial y squared minus 2y plus 1 is y minus 1 squared equals 1. So this is a circle with the center at 0, 1 and a radius of the square root of 1, which is just 1. And that's how you convert from polar to rectangular.